According to Dr. Lamont Murdoch from Loma University School of Medicine, genetics may set the stage for potential health issues. The human body is a community of more than 50 trillion cells under our skin, each functioning independently. They are the structural foundation of the body. Cells have a mind of their own. They unite to form tissues, organs and systems. Cells do not compete. They cooperate. We are as healthy as our cells are healthy. Each cell is a microscopic world in which thousands of essential chemical processes are carried out. And even though cells vary, blood cells are different from nerve cells, and muscle cells are other from bone cells, they all have the same essential components and nutritional needs. Red blood cells supply oxygen and nutrient to every minute area of the body. Red blood cells deliver oxygen and nutrient to every minute size of the body. Platelets form clots in the blood to prevent us from bleeding to death if we get an injury or cut. The human body always does its best to maintain internal balance to keep us alive. If we become too hot, the body will regulate itself, and we will sweat until the temperature is back to normal. Even though we cannot alter our genetics, we do have the ability to modify our lifestyle. By making confident choices in our daily lives, we can prevent or delay the onset of diseases we may be genetically prone to. According to Dr. Lamont Murdoch from Loma University School of Medicine, genetics may set the stage for potential health issues. Still, it is our lifestyle that ultimately determines whether or not these issues manifest. We must pay attention to the signals our body sends us. What we disregard today could become a chronic illness tomorrow. The human body has a vast community of over 50 trillion cells, each functioning individually. The disease process also follows this principle. The immune system collaborates with all other methods to restore the body to its normal state. Our thoughts and emotions, psycho, interact with our nervous system, neuro, to support the healing process, immunology. Through a language of biochemicals and nerves, the mind and body maintain constant communication. Stem cells are produced in the bone marrow, and other cells derive from these stem cells. White blood cells, specifically phagocytes, play a crucial role in our defense system. As the body's largest organ, our skin acts as the first line of defense, providing physical and chemical barriers against external elements. Beneath the skin, special glands release specific enzymes that aid in eliminating bacteria that enter the body. The skin serves as a protective barrier for most parts of the body. However, the respiratory system is lined with a mucous membrane that produces mucus to capture irritants entering the nose. Additional safeguards are in place to prevent foreign particles from reaching the lungs. Macrophages comprise approximately 5% of white blood cells and are crucial as frontline defenders. They communicate and call for reinforcements when needed. They can be referred to as big eaters on occasion. When they are circulating, they are known as macrophages. In the blood, they can be located in the fluid surrounding inflammation. Their role is to scavenge and digest foreign invaders. These frontline foot soldiers comprise 62% of white blood cells with a short lifespan. In healthy bodies, they remain constantly active daily. They engage in attacking and eliminating bacteria and engulfing harmful microorganisms. Additionally, they are responsible for destroying lifeless particles such as asbestos and cellular debris. T helper cells serve as the commanding officers of the defense system. Signals are sent by them to other immune cells, which then spur the immune system battle. Their responsibility lies in sending instructions to all cells involved in the immune response. T helper cells possess specific training in the thymus, enabling them to recognize different invaders individually. These cells can be considered commando units that directly destroy virus-infected cells. They undergo maturation and training in the thymus and are stored in lymph nodes and spleen. Specific hormones only activate one program for a particular virus. T suppressor cells can be likened to military police as they restore the immune system to its normal state after defeating an invader. Like T and B cells, they mature, train in the thymus, and communicate by sending messages. Eventually, T and B cells slow down and ultimately cease their activities. Matthew, thank you for spreading awareness, and I hope this video reaches a broad audience.